Cool. Yeah, so just take your time here whenever you guys are ready. Feel free, just let me know, and yeah, awesome.
Hello, everyone. Good evening. Welcome, welcome, welcome you.
Still muted there.
Good evening, everyone. Okay, so my name is Odwai Abdako, and we're going to kickstart right away. Ryan, welcome. I can cite you already. Good evening. How are you doing?
Thank you. Yeah, I'm good. How are you all?
I'm fine too, and we're all good. Good. Okay, so I'm going to talk about SCIENCOON. SCIENCOON is a Nigeria-based science club that gives students a place to express their scientific curiosity, develop their scientific knowledge, and pursue their interest in engaging in scientific activities. So what's our goal? Our goal is to host seminars, workshops, school outreach, and career mentorship, exhibitions, quiz competitions, and other events to foster students' knowledge and expertise in the sciences, with the focus of the life sciences. And this club provides opportunity for like-minded people to join through membership, volunteering for the projects and programs. Members of the club were from different areas of life science, and including every individual who has interest in science. So more like our seminar today, our webinar today, that's one of the club's goal. So what have we achieved so far? We've embarked on day-long school outreach programs spanning a period of 5 weeks, which involved visits to selected secondary schools within Akure. During these visits, we engaged students in science discussions for them to understand various scientific concepts. We distributed learning materials. We distributed learning materials to enhance ease and comfort in their academic growth. Then we host webinars monthly spanning topics like neuroscience, astrology, like we have today, career, astrobiology, and space medicine, we have careers, scientific publishing, and for this very month, this month of September, we have invited Ryan Kebi to talk on astrobiology and space medicine. And then I'm sure most people are really wondering, okay, what exactly is space medicine? What it is? Okay, for me, before I even start, or before our speaker is going to tell us, I was thinking, is it possible is like being a doctor in space, or maybe a particular drug or medicine that is given to people in space? But right here today, Ryan is going to be giving us introduction into space medicine, into astrobiology, what they mean, and then it is going to help us to know how students can enroll into such programs, and then we're going to know the requirements of what it takes to be a space scientist. And also we are going to know the impact of space scientists in space research and career opportunities available. So maybe you've always had this in mind, like, I really want to go into space. And I think he's really going to tell us about what space is and how you can actually achieve that dream of yours. So before we continue, can you let us know in the comment section where you're joining from? And can we do that? Okay, maybe I should. Okay, someone is saying that's Sim Saka Palit from India. Okay. Nigeria. Okay. Let's keep it coming. Let's keep it coming. We have India, Boston area. Wow. We have Nigeria. Wow. We have India. Wow. That's awesome. That's awesome. That's beautiful. So without wasting too much of our time, and it's also interesting to let us know that we are recruiting members into our club. Like, anyone who's interested in joining SCIENCOON, you are highly welcome. So without wasting too much of our time, I would like to invite our speaker to. So before that, Ryan Kebi is. Are we guessing? Okay, I want to read his bio now. So Ryan Kebi is an astrobiologist and space/planet scientist. He has worked as a supplemental instructor for astronomy, and he has traveled to Africa to teach students at Shamal Senior High School in Ghana. That means he has been to Africa. So it's possible we will bring, Ryan to. Ryan, are you willing to come to Nigeria?
Oh, that would be wonderful.
Okay, so he works currently as a part-time as an astrobiology instructor for middle school age youth from across the world with the online educational startup, The Act of Inquiry, and is a contractor editor for articles for the Commander's Herald that blends real-life science with the fantasy card game Magic the Gathering. So interestingly, he published a book in 2020 that introduces novice to astronomy and stargazing. Ryan, I think you can drop the name of your book so that we can probably check it out after this meeting, so we can have more insight into what astronomy really means. And then during his time in college, he developed remarkable writing and communication skills and continues to refine these skills as a visiting scholar at the Blue Marble Space Institute of Science, BMSIS. That is a non-profit organization that specializes in astrobiology research and citizen scientist engagement. So with BMSIS, he has focused on developing a website for Braille, and that's a NASA project to study life in volcanic caves and determine this life using walking robots in a simulator mission for Mars. He co-manages Braille's online presence and help that team members communicate their activities to a broader audience. He enjoys creating graphic arts and animations to help convey scientific concepts, astrophotography, and playing board games. So with a clapping ovation, I believe. Can we all welcome Ryan to today's webinar? Ryan, you're welcome. I'm so excited, and it's really, really going to be fun for us to listen and to hear from you. You're welcome. You're welcome.
Thank you very much. Yes, and I put a link to the book in the chat. Although please,
Right.
I think it's very informative and very fun, but by no means does anyone you should not feel obligated to buy it. Yes, so
Okay. Can we all can we all see the link? So we can just check it. Ryan, you can go.
all right. Yeah, do you want me to get started? I'll share my screen and get going if that's cool, if that's all right with everyone. All right. So I hope everyone can see the presentation here.
Yeah.
Yes, I can. Yes.
Yes, we can.
Excellent. And I've got the chat open on my other screen here. So as anyone gets questions, you can feel free to throw them in the chat. And I'll try my best to address them as quick as possible. But there'll be plenty of time for questions at the end as well. So I think my main concern is hopefully you guys come out of this with something fun and interesting and a little bit of knowledge about how you can get involved in the field. So space medicine and astrobiology, I think this is a big part of the future of space sciences. We're heading into a world where it is incredibly important to understand what happens to people in space. So I titled this The Future, right? I mean, there's a lot of stuff going on in the future, but I think this is very important. So here's just a quick agenda. I'll briefly mention myself here. I don't want to spend too much time talking about me, but we will spend a lot of time talking about astrobiology and then about space medicine. And then probably the most exciting part is how you guys can get involved in that. And then we'll just have a quick wrap up, which will lead into our... So just a little bit about me. Some of this has changed because I'm really bad at keeping up with my online presence. But mainly, my interests are pretty similar to what they've been for a long time now. Science communication, education, and outreach. Particularly in the fields of astrobiology, astronomy, and planetary sciences. I'm also very interested in an avid astrophotographer and graphic designer, particularly graphic design that relates to science, but
Hello.
Hello.
Just can we do well to mute while joining the meeting? Thank you.
Okay, yeah, good evening.
How
was the day?
All right. So sorry about that. I'm also very interested in climate sciences and education. I won't talk about that today, but there's a lot of crossover with climate science and astrobiology that I encourage everyone to explore. Some of my experience that is still going on today, I'm still a visiting scholar at Blue Marble Space Institute of Science, which I'll talk more about at the end when it comes to getting involved. I'm also a math, science, and technology teacher at a school in this area now. And I'm a team communications officer for Team Life 2 and Beyond. You can see our symbol down here. And this is the Blue Marble symbol. So if you find those online, they are excellent places to look for resources. I see someone in the chat asking about hearing. Do most people hear me okay?
Yes.
Okay.
We can hear you.
I can. Can we hear him?
Yes, we can.
Yes,
Awesome.
we can.
Great.
All
Just
right.
making sure.
Thank you. I
Yeah.
think it's just the one. You can try reconnecting.
All right. Awesome. So, and then usually this slide is a lot shorter than it is right now. But I did want to mention a little bit about my research just to get people a better idea of what people coming into astrobiology do research on. I think that's really important when we talk about some stuff a little bit later on. But so some of my past research has involved mapping the ages of star clusters, which have thousands of stars in them. So they're kind of a daunting process to try to figure out the ages of, but there's some really cool ways to do that. Also mapping glacial decline over time. This is part of what really got me interested in that climate science stuff. And lastly, deriving the ages of ancient lava flows on Mars. So some stuff that probably doesn't sound a lot like astrobiology, which is true. These were things that I did before I even really knew that astrobiology was a thing. But it shows you a little bit about my background. It's more in observational astronomy and kind of remote sensing than life sciences, at least at first. And this brings up the question of what is astrobiology, right? I have a kind of a weird background to be going into a field about life. But just as this quote says here, everyone is an astrobiologist. They just don't know it yet. This is Dr. Mary Voitet, who is currently the lead researcher in astrobiology at NASA. That's her title, not necessarily that she's, the best person doing research in it, although she's fantastic at it. But there are a lot of great researchers. So what is astrobiology? Well, before we really get into content-wise, I wanted to focus on 3 really important points of astrobiology. Astrobiology is a hugely interdisciplinary field, which means that people from many backgrounds can get involved, which is amazing because it means that we can collaborate together. We can communicate with a bunch of people from all over the place and always be learning new things, right? Because my expertise will be totally different than your expertise. But we collaborate together and work with those expertise. And that can help us actually understand a more meaningful conversation about astrobiology. So these are 3 really important things that are necessary for an astrobiologist. Actually, I argue that when you leave this, I hope that these are the 3 things that you take away, if nothing else. An astrobiologist has to be able to collaborate really effectively with other people. They have to be able to communicate really effectively with other people as well. And they have to be able to always continue learning. Astrobiology is a weird field because it's not one that you can kind of initially specialize in. You specialize in a different field and then you come together to answer a bigger question. So these are hugely important for astrobiologists. They're probably these are the 3 things that every astrobiologist has in common. They have to be good at these 3 things. Everything else can be different. But what an astrobiologist actually researches is important. So I put 3 main things here, but there's a lot of things that astrobiologists research. It's a very big field, although it has some pretty niche topics. For example, is really big, right? It's a fundamental question about where life comes from. Where did it start? Could it have started somewhere else and come here? Or did it start here? If it started here, can it start somewhere else too? Right? So the origin of life is a fundamental question about where we came from. And it really helps us answer if there can be other stuff like us out there, other living things. That is one of the big questions of astrobiology. Where did life come from in the first place? The other is there other life out there? And if so, how can we find it, right? So that's our second question here. What other life can exist? Where can it exist? And how do we know if we find it? How do we know if we find it is kind of a weird question. You would think you see something and you know it's life. But there's a lot of nuance there because when we think about life here on Earth can be incredibly diverse. We have things like single-celled organisms and viruses. And then we have things like humans and elephants and giant birds and tiny little things underwater. Life looks incredibly different wherever we look on Earth. So when we look out into the stars or the other planets, it can look incredibly different. So we have to keep that in mind. And it's going to be really important for us to try to figure out how we truly define life, because that'll let us know if we actually find it out there. The other thing is humans going to space. And this is going to be a bigger part of the conversation today than the other parts, because we're really interested in space medicine. So when we send people to space, how can we do that safely, right? What can we learn from humans that have gone to space? And how can we make sure that they stay safe while they're up there? And how can we make sure that they're safe when they come home? So there's a lot of important nuance in all three of these questions. We are going to obviously focus a lot on this last one. But these are kind of some of the biggest questions in astrobiology. So I do want to spend just a slide on each of them at least. The origin of life, you probably all have something of a background hearing about this before. But I just wanted to point out one major experiment, which is the Miller-Urey experiment. If you've taken a organic chemistry class, you've probably heard of this before. If you're really lucky, maybe you've even done a similar type of experiment. But this was an experiment done by two chemists and biologists back in the day, a long time ago, where they essentially had a bunch of chemicals that they thought represented the environment in the early Earth, the atmosphere of the early Earth. And they would have them cycle through this tubing system, and they'd have some energy source, right, a heat source. They would have, I think of the first example of this was actually with like electrodes that would just send a spark through the thing, not actually like a Bunsen burner here. And this would energize the elements and the compounds in here. There was nothing organic at first, but this brilliant experiment proved that you can build simple organic building blocks and macromolecules through this kind of complex soup of molecules. So that doesn't mean that we built life. We still don't have proof that abiogenesis is possible, which is this creation of life through these inorganic molecules. We don't have proof that that's actually possible yet, but we do have proof that we can build some stuff that might help us make life eventually. So there's still something missing between this experiment and this abiogenesis possibility, which leads to other theories, right? One other popular theory that is less popular today than it was when it was founded is this idea of panspermia, which means that life might have started somewhere else and been deposited here in our solar system, here on Earth, among other places. And this is one of the big reasons why the origin of life is important to an astrobiologist. If we understand that life started somewhere else and came to Earth, right? If it got deposited, for example, the first cell on Earth, was it created through this abiogenesis process of non-life things eventually making life? Or did it get dropped here on accident? If we understand that, then we can understand, that might help us understand what life might look like elsewhere. Did it have to go through the same abiogenesis process? Or was it a similar type of life that started here, deposited somewhere else as well? We won't spend any more time talking about the origin of life, but there are some really interesting questions in here. And you can see how interdisciplinary this field is, because here we're talking about chemistry and organic chemistry and fairly complex biology topics, right? But when we move into the other type of life, right, what other life might be out there, we're going to talk more about planetary science and astronomy and radio observing. So here, again, we won't spend too much time on this one, so we can talk about space medicine. But this talks about what other life is out there, right? So we can look for life really far away. To do that, we'd have to look for certain chemicals in the atmospheres of faraway planets. We would also have to know if a star is capable of sustaining life, right? If that system might be able to. And then we have to know about the planets in that system. Can they sustain life? So there's a lot of stuff that goes into trying to find life really far away. But there's also a lot of stuff that has to go into finding life close to home. This would be things like on Mars or the moon. On Mars, we're not expecting to find anything big, but we might find microbial life, really small stuff. To really understand how we can look for this life, we have to do things like analog studies. We have to train robots. We have to learn about the subsurface of planets, right? What's underneath planets? We have to learn about oceans and how life might start in oceans. This is one of the most famous examples of kind of an astrobiology hotspot here on Earth, here in our solar system. This is the moon of Jupiter called Europa. There's a huge layer of ice on its surface. It has all these giant scars on that ice. But under that ice, there's a ton of water and a ton of energy, heat. Water and heat, those are pretty important to life. So we think that it might be possible that there might be some small forms of life under that thick ice. So a lot of people from the astrobiology field are looking at how we can really analyze this planet or moon to see if there's life there. And the last way that we can look for other life out there is SETI, which is the search for extraterrestrial intelligence. In other words, the search for life far away that's also really smart, like us. This uses things like radio astronomy, directional astronomy, computational analysis, and instrumentation. So we're looking for signals from other life, right? That's really far away, but we're looking if they sent anything to us. So these are really the three ways that we try to look for life, but you can see that there's so much that goes into this. Chemistry and stellar astronomy, planetary sciences, instrumentation and robotics, marine science and biology, computational stuff, right? So again, I'm just trying to reinforce that idea that astrobiology is such a big field. There's so many different areas of expertise. And here, we're going to move into talking about humans in space. This is the main reason why we're even having this discussion today. Space medicine, right? Which comes from this idea of people going to space. So here I have a couple of examples, right? So NASA sent people to space back at the end of the 1960s, or to the moon at the end of the 1960s, in the Apollo missions, right? And now we're going back with these Artemis missions. One of the reasons that we're going back in Artemis is to look at stuff that we left there last time. We learned that humans can survive on the moon. We learned how to make them survive there for a time. What we didn't learn how to do is bring our waste back with us. It's kind of gross, but we had all of this human waste, right? And it took up so much space on our spaceship, and we wanted to bring back moon rocks, not people waste. So the Apollo astronauts left it there. They left these garbage bags of human waste. Now, as life science students, you might know that in human waste, there are microbes and germs. It is really interesting to some astrobiologists if those germs have survived on the moon. They've been there for a long time now. So part of the Artemis mission, which is going back to the moon, is going to be to look at that waste to see if anything has survived. That'll tell us a lot about not how humans can survive on the moon, but how other things might be able to. And if we learn about that, we might be able to apply that to how humans can survive there. one of the most important man-made laboratories for humans in space is the International Space Station. A ton of research actually gets done on the International Space Station, but it's also just people are housed there for a long time. So when people live in space, like on the space station, they have to keep things in mind, right? This kind of changes the way we live for a bunch of reasons, right? There's the more obvious reasons, like gravity being different. But there's also something that I wanted to emphasize here, which is the scarcity of resources. On Earth, we have come to believe that resources are abundant and easily accessible. They won't be forever, which we have to figure out how to manage. But in space, we learned really quickly that we need to be cautious with our resources. So I just have a little note in here kind of, emphasizing that climate science piece, right? We have to begin thinking about Earth resources as if they're not limitless. We should be utilizing the stuff that we learn from space and applying that here on Earth as well. And we do, but we have to be more considerate of that. So when people live in space, they really have to readjust their lives, not just for the physical things, but also like resources and things like that. There are also the physical things, right? When we go to space, we still have to do things like use the bathroom and brush our teeth, right? This is all health stuff, right? When we think about medicine, we often think exclusively about things like, painkillers and sleeping pills and things like that. But medicine is a very broad term, right? It actually applies to things like toothpaste, right? Dental care, and even as far down as like seatbelts, right? Safety equipment. One big part of toothpaste in space is that it's not as easy to use water in space. So they had to make edible toothpaste that you didn't need as much water to use. And they also have to begin recycling urine, right? That helps us kind of keep water available in the space station. Now, the reason that I bring this up is because while recycled urine, being water, isn't necessarily a medicine, it is still an important piece of keeping people safe in space. This is a huge engineering feat, a recycling toilet, that one is used in space and should be used here on Earth, but also it is but it is also a piece of medical equipment, right? This helps us make resources that we need to survive. So, and one more thing, just to kind of just to keep emphasizing the idea that space medicine is not just pills and doctors in space. It can also have to do with food, right? Food and water are fundamental resources that humans need to survive, whether they're on space or on Earth. So here, I have just a little slide about vertical farming. This was invented so that we could start growing stuff on the space station. And we've done that now. We've actually grown a lot of stuff on the space station. One of my friends that I was working with when I did communication work with NASA, he is a space botanist, an astrobotanist. And he was telling me that there's this famous story in astrobotany about one of the early times when they grew kale in space. All the astronauts aboard the International Space Station ate it. And they ate a bunch of the vegetables they grew, right? And they couldn't figure out why, but they didn't like the kale. So researchers down here on Earth were taking notes, and they were saying, okay, the astronauts don't like the kale. Something's different. Something is fundamentally different about the kale grown on the space station. And they couldn't figure out why. They were thinking maybe the radiation is degrading the DNA, making it less edible, which doesn't taste as good for us. They couldn't figure it out. They kept trying things, they kept growing new batches of kale, and eventually one of the astronauts said, when they told the astronauts what they were trying to figure out, the astronauts said, well, none of us like kale anyways. So it turns out the kale actually grew exactly the same on the space station, more or less. And just people didn't like it. So I always think that's a funny story. But the point of it, and the point of this slide, is to show you that another part of space medicine is growing food in space, right? So this vertical farming is actually a really useful thing because it takes up a lot less space than normal farming here on Earth. But it also allows us to do it in things like space stations, potentially in habitats on other planets. And we know now that things on the space station can grow just as well, right? We need to treat them a little bit differently sometimes, but they grow pretty well. So those are other parts of space medicine, right? Space resources, food and water. Here's just other things to think about when we talk about the International Space Station living there, right? It's developed other things for us, right? 3D printing tools became necessary, so they didn't have to keep sending new tools up. So they would just 3D print them, recycle them, and make new ones. Melting plastic. On the space station, they melt plastic that they send food pouches up in, and they turn it into tiles that they can use to reinforce the space station. So these are things that we can apply here on Earth once again. So while these aren't necessarily medicinal, it's important to keep these in mind when we think about life elsewhere. So 3D printing tools, right? These don't have to be exclusively mechanical tools. We can 3D print things like, dental tools and recycling our plastics. So we don't have to be as cautious about sending medicine up to space because the plastic that we send it in doesn't have to get just floated into space. We can reuse that. So that's enough of my biased climate talk. I think we'll transition into more traditional space medicine. But again, I'm just trying to reinforce the ideas. This whole field of astrobiology and space medicine is very interdisciplinary. There's a lot going on here. So this is a quote from Neil deGrasse Tyson. NASA has spin-offs, and it's a huge and very impressive list, including accurate and affordable LASIK eye surgery. So Neil deGrasse Tyson is a fantastic space communicator and scientist. So I think it's very apropos to have his quote here. But what he's talking about here, we develop things to use for astronauts or to use for space travel. And sometimes those prove to be very useful, like LASIK eye surgery. So we can use those not just in space, but also on here. So there's multiple parts of that space medicine stuff. So it's not just about being a doctor in space, although that is a part of it, but there's more to it than that. So really quickly, before we actually get into the different parts of space medicine, here's just a small history of space medicine, the start of it. And I want to emphasize that unfortunately, space medicine has a tragic past. Not just in what I'm about to tell you. I encourage you to look more into it. It is, there's a lot of things that have happened in the development of space medicine that we certainly would never want to reproduce. But this is the story of Laika, who is a dog that was sent into space by the Soviet Union in the 1950s. It was sent on Sputnik 2, which was their second orbiting satellite, which was a great feat to be able to send something into space and have it survive. And it did survive, which was fantastic. It survived for about 2 orbits of the Earth, and then it's unclear if it survived any longer, but it didn't survive all the way to get back to Earth. Laika did not survive the entire trip, but it did allow the Soviet Union to collect very important biometric data, essentially allowing them to figure out how living things experience being in space, not just emotionally, right? They couldn't really understand that, but they were able to understand how they react to space physiologically. Laika is a very sad story, but a very good puppy. So we should always remember Laika. But regardless, moving on just a little bit, in 1961, so just a few years later, and in the meantime, a lot of other animal experiments were happening, sending things to space, but NASA was able to send a chimpanzee to space called Ham, and this chimpanzee was able to survive coming home. This is incredibly important. This is a breakthrough in space medicine, because this meant that now we know that things are not changed forever from going to space, at least for a short time. So, so it was able to, Ham was able to survive all the way back home, and Ham lived a pretty normal life for a chimpanzee afterwards. Unfortunately, animal testing does still continue today, although a lot of that is on the ISS, and it's not done in ways where, Laika, for example, probably did not die an enjoyable death, unfortunately. But it's a little bit more humane today, but it is still going on. So again, space medicine has an unfortunately dark past, but if we move into more modern space medicine just a little bit, we see that a lot of other stuff has happened since. For example, Project Mercury is us trying to send humans into space. And this happened. That animal testing that was unfortunately an unfortunate part of our past did help us understand that living things can survive space, right? Ham the chimpanzee told us that. So now one of the major concerns in Project Mercury was they weren't sure how a human would react to the isolation of space. This was the cabin that they had, and it fit one person. So you could imagine it would be pretty isolating in there. This is also when humans learned that couches and seatbelts were really important for space travel, which sounds obvious today, but this is the first time it was implemented, which is great. And again, like I said, these safety devices are actually a part of space medicine. And then if we skip forward a few years, a mission actually ended in a tragedy. It was a test to like a simulation, and a fire started in the cabin that was full of flammable material, right? This cabin was made out of flammable stuff. The astronauts on board died, unfortunately. 4 astronauts died. And so because of this, NASA realized that there were other concerns than just psychological and physiological concerns. The safety of the actual device was important. They stopped using things that were easily flammable, and they actually developed a strong flame retardant suit that was later ended up being used in fire departments for a very long time, and has influenced modern firefighting equipment, which is great. And that's another avenue of space science, space medicine, is developing tools that are very important not just for space, but end up being important here. We call these space spin-offs. And real quick, in the middle here, we had these Mercury projects, we had the Apollo project, but along the way, we also learned that that it wasn't just psychological concerns, right? They thought it was just going to be psychological concerns at first, but it turns out we learned that there's actually bad negative effects on our bodies from space travel. So astronauts, for example, on these trips, they experienced loss of balance, they experienced difficulty with anaerobic stuff, but they generally recovered pretty well when they got back to Earth. It just took some time. So we learned that it wasn't an immediate shift like they thought. They thought that in space, maybe your body acts different, but when you get home, it's fine. And it turns out that wasn't the case right away. So while ham turned out to be fine, and this is kind of one of the birthing points of true space medicine. And this is where I separate space medicine into three parts. I consider medicine, and these are terms that I came up with. These are not terms that are generally used, but these separations are generally used. For example, there's medicine that's used for space. This is stuff that's been developed to be specifically useful because of things that people experience in space or on their way to space. For example, sleep and nausea medicine that's particularly effective for people that are in space is really important. And emergency supplies that are actually useful on the space station are important. For example, EpiPens don't work the same on the space station because of the gravity, so they had to make new things. And also, as many people know, we learned that we have to use persistent muscle training on the International Space Station because otherwise we will develop muscle atrophy, and that's not good for us. So there's medicines that we use for space, but then there's also medicines that have come from space. By this, I mean things that we've learned from space, not necessarily stuff that we use because of space, but this is stuff like the research that's going on that muscle atrophy. Human bodies react to microgravity, right? Like on the space station. There's also the psychological stuff, right? We still don't really have a great idea of the long-term psychological effects, right? We know that that was a concern back in the 60s, and we still don't have a great understanding of it, but there's a lot of research being done in that. There's also kind of newer concerns that we've learned about, like cardiovascular health and radiation exposure. So it turns out that when we're in space, since gravity is different, our blood flows differently, right? It takes more work for it to flow. And the same is true for, radiation in space. We're getting exposed to radiation all the time. We have to figure out ways to combat that, right? If you've ever gone in for an X-ray, they usually have exposure to X-ray radiation as they can. In space, we try to prevent astronauts being exposed to too much of it, but we are also still learning the consequences of being exposed to it. So this is medicine learned from space, whereas we have medicine that's used for space travel. And then there's medicine that we've learned from space that's now being used here on Earth. So this stuff in the middle, this is stuff that we're learning while we're in space that's still being applied to our astronauts. This is stuff that we have learned successfully and are now implementing here on Earth. This is things like radiation therapy, right? That radiation exposure, learning about it has helped us learn that radiation can be used to combat cancer. Personal alert systems and remote diagnostic tools. Every astronaut that gets sent into space is equipped with personal alert systems and remote diagnostic tools. This way, people from home or from Earth can be monitoring them to make sure that if they don't wake up in the morning at the normal time for some reason, they understand what's going on. Their blood pressure, they know that their blood pressure is normal, so they're probably fine, right? Things like that. And then there's things like MRI and CAT scans and pacemakers. These were developed in part because of research that was done to help astronauts survive in space. So these are those space spin-offs that I mentioned. So these are the three main points in space medicine. And there are researchers that are doing research in all of these. Not all of them are doctors, by the way. This is a really important piece. You don't need to go to med school to become an astrobiologist or someone that works in space medicine. if you want to be a doctor for astronauts, you probably will need to go to med school. But if your goal is to learn about the impact of muscle atrophy, you might not need to. It really depends on what other people in the field do. So there's also a ton of people like engineers and people that work on instrumentation that are heavily involved in space medicine because of some of this stuff, right? Understanding how we can still interpret signs of things that are happening at the space station is really important to make sure that our astronauts are safe. So that's a bit about space medicine. I kept this a little bit short. There's a lot more about space medicine that I'm happy to talk about if people have specific questions, but I did want to leave myself a little bit of room to talk about how to get involved. I cheated and I copied a quote, as you already see. Everyone is an astrobiologist, they just don't know it yet. I know, I used this earlier and you're mad at me, and that's fine, but I think it's powerful enough to use twice. The reason is because I used it early on when I tell you who I am, because my background is not necessarily in biology, right? I have a understanding of biology from college, but that was not my original understanding. So I've learned quite a lot about biology since I've been a part of the field. But again, my research was in astronomy and it was in lava tube science, right? So getting involved in astrobiology, for me, it wasn't an immediate transition. So I'm reusing this quote for that reason, and also because, and again, I encourage you to look a little bit more into the history of space medicine. A lot of people that were heavily involved in early space medicine were unfortunately people who are terrible people, to be honest. So getting a quote from one of them doesn't feel very apropos. So using a quote from a very renowned person today is a little bit better. So I went a little bit goofier on this slide, but this is some tips on becoming an astrobiologist, a space scientist, a space medicine researcher. 1, find your field of interest. Astrobiology is not a field you can major in, right? You've probably noticed this in college. You might not even have an astrobiology class. Some schools might have an astrobiology class, but no college has a bachelor's degree in astrobiology that I know of. This is because it's so interdisciplinary and there's such a wide range of sciences that what happens is people have their expertise and then apply that to life sciences, and that's, or astronomy rather, if your expertise is in life science. And that cross-pollination of subjects is what bleeds into astrobiology. So focus on your field, right? Find what is interesting to you. Is it chemistry? Is it biology? Is it astronomy? Is it how the planet moves, right? Whatever it is, focus on that, and then think about ways that that connects to the other parts of astrobiology. How does chemistry, how does your specific interest in chemistry relate to the origin of life, or how life might be, how we might find life elsewhere? So again, just focus on your field at first and see how it connects to astrobiology. And on a similar vein, know what to look for, because astrobiology jobs, right, just like degrees in astrobiology, are hard to come by. A job in astrobiology, or rather, a astrobiology job isn't very common. Even at NASA, there's very few astrobiologists. but there's a lot of people that work in the field of astrobiology. For example, there are plenty of roboticists that have worked on the robots that we used in the NASA expeditions that I've gone on. And these people are astrobiologists by trade, but that's not an astrobiology job. They were roboticists who worked on an astrobiology project. And that's how most people are involved in astrobiology. For example, maybe you really want to be a doctor for astronauts. Then you should go to med school. You should figure out what part of medicine you are very interested in and focus on that. And then look for jobs about astronauts, right? Look for jobs that allow you to use your medical expertise in space. So this astrobiology is a word that, and the use of astrobiology is still a very growing topic, that word, astrobiology. And the same is true for space medicine, right? These are growing topics. They're appearing more and more, but it's still technically hard to find a astrobiology job because that's just not really how they're advertised. So when you're looking for opportunities or jobs, again, you want to look for things in your field that are starting to relate elsewhere. And the other thing I want to say and keep in mind for everyone to keep in mind is you want to seek help from other people and organizations. There's a ton of organizations and communities that look for people to come into this field. And people in the field understand that it's a hard one to find because, again, this use of astrobiology and space medicine and all that, they're still growing terms. So there's a lot of sharing of opportunities in these groups. To go along with that, here's just a couple of examples of these groups. And again, this is another reason why I wanted to focus a little bit more on the About Me page than I normally would, because I was a member of this Young Scientist program at first at Blue Marble Space Institute of Science. And there I got connected with a huge array of experts in different fields. I met a ton of people from both inside Blue Marble and outside of Blue Marble, and they helped me facilitated connecting my expertises into the field of astrobiology. There's also a lot of opportunity to grow at Blue Marble. Blue Marble has a growing young scientist program. Every year, there's more and more young scientists that go there for the summer. And that's what happens is it's an online program in the summer where you do research, you help do research with a visiting scholar or a research scientist there. And during that time, you get a bunch of different skills, you meet a bunch of people, and depending on what you do, you may be asked to continue working there, or you may ask to continue working there as a visiting scholar like I have. Eventually, you can also become a research scientist there if you like. The other organization that I wanted to point out here is, again, I'm the team communications officer here at Life to and Beyond, which is a youth-focused and run initiative. We run a lot of outreach events, just like you guys here. We try to get a lot of people involved in the field, so we offer opportunities for a lot of young people to give webinars, a lot of young people to just simply get involved in both outreach, education, research, all sorts of things. We also like to keep everyone up to date on opportunities, global opportunities for people to get involved, both jobs, research, internships, things like this. And here's just one example of that is the Spacepreneurs program, which is a part of World Space Week, which is at the beginning of October. So Life to and Beyond is collaborating with a bunch of other places to host space entrepreneurs to talk to people about how to get involved. So these are two great examples, and here's some others, right? Innova Space, Space Crew, again, Blue Marble. LifeShip is a great organization that has some great intentions, and certainly following them is good. So these are great resources because, again, they give you these opportunity alerts. They know what to look for, right, to find jobs and opportunities, right? And none of these have any costs associated with them other than potentially your time, right? Which you would want to associate or commit to any position, right? So when I say to find your opportunity, right, or seek help from others, find an organization, these are just two examples of that. These are how I got involved in astrobiology and how I continue to be involved in astrobiology. But there are tons out there, a lot of different groups that seek to draw people into the field. And if they don't exist at your college yet, there's always opportunities, for example, with things like Life to and Beyond and Blue Marble, to bring that to your area. So I want to wrap up just with a couple comments and then open up to questions. So real quick, again, the most important thing, if there's one thing that you take away from this session, it's that the only things that every astrobiologist has in common is their ability to collaborate, communicate, and continually learn new things. If those sound like things that you do, then you are in a good position to continue going into the field of astrobiology. Remember that it's just too diverse of a field. There's so much stuff going on that not everyone has similar academic expertises, but they do have similar expertises in these three things. The other thing is outreach and educational events like this are great places to learn, not just from people like me, but also just to learn from other youth people. Again, I ask that you reach out to researchers that you think do particularly interesting research. Astrobiology is a huge field in concept, but again, fairly few people, when you consider all of academia, actually research astrobiology concepts. So when you find someone that does really interesting research to you, you should reach out to them and just see if there's any way that you can connect with them. And lastly, focus on your interests and you can apply those to astrobiology. So I'll open up to questions, and in the meantime, I'm gonna just post this in the chat. I know that a lot of people here use WhatsApp. This is a WhatsApp channel for Life to and Beyond. So you can just join that for free and just hang out in that and talk to people. I'm in there. You can, at me and say that you enjoyed listening to my thing, or ask me any further questions on there. If you can't think of questions right now, but you want to write some stuff down, you can find me on my own on WhatsApp or through this link and connect with me, and a bunch of other people have used that link. So that is my whole presentation. I'm happy to elaborate on any part of it, but I wanted to keep it pretty condensed just to open up to questions still. So.
Wow. Thank you so much, Ryan. My first question that I asked, I said I was really thrilled at this class or this webinar, that I was thinking, is space medicine really about, okay, the doctors there, or maybe the medicine, the drugs that I use? And now I've really learned. Can you all kindly drop maybe one or two things that you've learned? For me, one thing that Ryan said is more like, find your space. Everyone can be an astrobiologist. So it's not like maybe there's specifically what's called a course for that. So you just need to find your own expertise and bring it into that. Find what works for you. And another thing that I learned is space medicine is not just about drugs, but also our daily life activities. And another profound thing that you said was that it's so interesting how the things you use there on space, we bring it down here for the advancement of life here on Earth. That was so profound. I was like, wow. Thank you so much. We are really grateful. So if you have questions, can you send your question? Maybe you can signify or send your questions to chat box to ask Ryan, and I'm sure he's really willing to answer us. Questions. So, okay. Ryan, I have a question. It's still related to space medicine. Is there a way to I think my questions might be funny, but then still, is there something about maybe healing the solar system, right? Like, is space medicine really like about that? Maybe like you mentioned Mars, different solar systems. So is space medicine really about that too, or I don't know.
Yeah, help me a little bit if I'm wrong here. Is the question essentially like, does space medicine extend to humans on Mars or on the moon as opposed to just the International Space Station? Is that the question?
I didn't get you. Sorry. What did you say?
No, that's okay. I was saying, is the question essentially like, does space medicine and astrobiology extend beyond the moon and the International Space Station? Are there people doing research in like how the body reacts to Mars, for example? Is that your question?
No. I think my question would be, let me explain well. More like,
Yeah.
is it more than the people involved, or like maybe something you want to check a change in the math and probably try to see what we can do better with the solar systems that we have there. Okay, if you don't get, let me read the questions that people have
Okay.
here. Okay, so someone is asking, given the advancements in space exploration and considering the biological requirements necessary for life in space, where are we most likely to colonize first, Mars or the moon?
Yeah, that's a great question. I think, you know, we are much closer to the moon. So in terms of making settlements somewhere else, I think it is natural to assume that the next step will be the moon. And I think that's
Okay.
with good reason. Our current plans to get to Mars involve making a small base on the moon. so so it seems that most people in the field assume that we will have established settlements on the moon before heading to Mars. Uh, although
Okay.
there are, you know, there are differences. For example, there are people doing research um, in using caves as a habitable place on another planet. For example, caves actually protect from a lot of bad radiation, so you don't have to worry about building a big structure. You just slap a door in a cave and you call it a home. I mean, that's overly simplified, but and on the moon, there are much larger caves, so that would make a much better home. So I think we are much more likely to get to the moon first for a variety of reasons, and that's one of them.
Okay. I think the person got the response, the answer to that. So the second question from that person is, are there any materials we can go to for more knowledge on space medicine and related subjects? So I think Ryan dropped the link to his book, or maybe you have more to share with us. Would really appreciate that too. So are there any materials that we can go to for more knowledge?
Yeah, absolutely. There are definitely other places to go to. Uh, I will say that one that I'm fairly familiar with is, for example, NASA Astrobiology. If you go to the website for, let me see if I can. There we go, homepage. And I'll just copy this into the chat even. This is a great resource because they have news, right? They also have deadlines for upcoming things. For example, a poster for SCIENCON, which is astrobiology science convention. There's also workshop notifications and deadlines. There's the news articles here. There's upcoming events. There's funding opportunities. So this is a great place. There's also, you can look at a map of field sites. You can read about Mars stuff. You can sign up for their mailing list, which will send you mail every month about different events and opportunities. There's even a podcast here if you go to Ask an Astrobiologist. One of my mentors here, Graham Lau, hosts Ask an Astrobiologist, and they interview different people. This is about Mars. This is an asteroid sample return. So they talk about that. So you get a good idea of all the different parts of astrobiology by listening to some of these episodes. So this is one really good tool, one really good place to get information from. But there are so many others. And I'll leave you with this one and that WhatsApp link. And you can go through these and you can find, here you go to resources and they link all sorts of different stuff here. So, play around with these websites, find them. Find me on WhatsApp if you want more links, and I'll happily send them to you.
Thank you. So I think Ryan is giving us access. Right. So let's celebrate. Let's clap for Ryan. Ryan, thank you. So another question here is, how does astrobiology intersect with the field of physiology? And what insight can it provide into the limits? Okay, before that, right, there's a question. Oh, well, it's still related to physiology, but this person is asking, I'm asking on behalf of other disciplines too. Are there master's opportunities in space medicine for physiology, or maybe for other disciplines too?
Yeah, that's a good question. I think, so generally speaking, at a master's level, there are going to be more opportunities for astro to become a physiologist. And while you're in your master's program for physiology, look for ways that you can get involved in space science, right? And then you'll be able to you'll have an expertise in physiology, and you'll have a good understanding of a bunch of astronomy and space science. And then you can blend the two together. And that's how you can really get involved in astrobiology that way and space medicine. So I would say there might be some master's programs for it now, but there's still very few. Yeah.
So now to the person's question, how does astrobiology intersect with the field of physiology, and what insight can it provide into the limits of life in extreme environments? Did you get that?
Yeah, that's a great question. So physiology, right, like how living things move and operate, is a very, fundamental piece of life. Obviously, when we think about like gravity, our physiology is different when we're in space. So that's a big intersection right there. But I think actually physiology is probably one of the most connected pieces to modern space medicine, because so much of it involves microgravity, and how our body operates is very different in that microgravity environment. So I think that it does have a lot of good intersections. And I think that when we talk about life in extreme environments, the second part of that question, there are really, really, really interesting things going on in extreme environments here on Earth, right? And that's really what we look at, because that works as like an analog to other places. So for example, and actually I saw something about this earlier on here, I think. Yeah. So this article I just read earlier today actually talks a little bit about, this is a methane vent very deep in the ocean. And this is stuff that lives on there. And so this takes a look at understanding how that impacts the life of those things. That's a very extreme environment. We certainly couldn't live near a methane vent like that. And then there's things like tardigrades, which can survive in very extreme conditions inside volcanoes, very deep and heated vents. And all of those things, the reason that they're really interesting to astrobiology is because other planets have weird and extreme environments, unlike the surface of Earth. So, there you go.
Okay, so the last question is, are there space physiologists?
Are there space physiologists? Yes, there are. I think actually Ask an Astrobiologist talked to one recently. Let me see. While I have this up, past episodes. So again, this Ask an Astrobiologist podcast is a great source to see what types of things people are doing in astrobiology. Without spending too much time looking, I'll stop here. This says how to detect life on ocean worlds and become a viral sensation with Dr. Lena Vincent. I don't think she's actually a physiologist, but this is, for example, talking about ocean worlds. Here, they're talking about the origin of life, defining life. Hot springs. So this is great about, an example of those extreme environments. So, again, I'm not seeing the physiologist that I saw recently on here right away, but yes, there are space physiologists who are doing very important research.
Okay, for the person that asked the question, I hope you got your answer. So another question here, Ryan, is would you like to share about human space programs from other parts of the world?
Yeah, so, I talked a lot about NASA. That is a bias of mine, is doing work with NASA, but also being from the United States means that I have a deeper tie or a deeper understanding of what NASA does. But there are great other programs out there. ISRA is the Indian Space Organization. I don't remember exactly what ISRA actually stands for, but they are doing great things, sending moon missions out now. And actually, that's what a lot of new places are doing. JAXA, the Japanese one, and many other space organizations around the world are really trying to get back to the moon, right? That's what a lot of us are trying to do right now, for various reasons. So part of that is astrobiology stuff. Actually, not too long ago, I think it was China had sent a space mission to the moon that was carrying a bunch of tardigrades, which are these really extreme tardigrade. I'll just show you a picture of them. They're an animal that live in really extreme environments and can survive a bunch of different stuff. It's the toughest animal on Earth or whatever. So it was carrying a bunch of these, and it actually dropped or crashed. But so the tardigrades kind of spilled out. So this was accidental, but they are hoping to, of course, go back and take a look and see if these have survived without the protection that they were intended to have. So yes, there's plenty of other space organizations out there doing great research, and many are doing research in the field of astrobiology, partly because it's incredibly important, right? I mean, the International Space Station is not going to be up forever. There are plans to stop it. I don't remember exactly what those plans are, but which is sad and I think a big misstep. But other countries are putting out space stations to kind of at least keep space science doing things in that way. So while we might not have an international space station for too much longer, there are going to be like the Chinese space station. I think America will have a new one. Russia is planning on having one. So yeah, hopefully that answers or elaborates a little bit on the other space organizations out there. There's a lot.
Okay, right. And another question here is an inhabiting Mars. Is it possible in our lifetime? And is there a possibility of humans inhabiting Mars evolving into a human species?
That's a great question. If we inhabit another planet like Mars, would we evolve? The answer is almost certainly yes. We would evolve differently, being in such a different environment. So that's interesting, but the bad news is that it takes millions of years for that evolution to happen. So we won't see that evolution anytime soon. But it is we can be very confident that humans living in such different environments will evolve differently. So yes, but not for millions of years.
Okay, so thank you. Another person said, okay, I love your design, sir. So what software were used for the designs that you would like to know?
Oh, yeah, sure. That's a cool one. So I use this is canva.com. I think it's just .com. That's what I use for my PowerPoints and presentations. It's a very easy to use tool, which is great. I also use Adobe software to make kind of more intense graphical design pieces. But Canva is very good. It's free and it's very good to use for things like this. There is a paid version, but you can certainly use it for free and get it by very well. The Adobe software is very expensive and I wouldn't recommend it unless you plan on doing a lot of graphic design. But I would recommend Canva.
All right, thank you. So another question is, what ethical considerations are associated with astrobiology, especially in terms of potential discovery of extraterrestrial life or the effect of human exploration on other celestial bodies? Did you get a question? I should read it again.
Yeah, that's a great and very important question. And it's not one with a simple answer, but it is one that's being explored, right? Actually, if anyone here ends up a part of this young scientist program, there's a non-optional, a mandatory piece of that is doing an ethics program about astrobiology and ethics. I know that Pallet, who has been putting in some comments, just recently, congratulations by the way, has graduated from the Young Scientist program, and had to go through this ethics module, and I did as well. And I would call it pretty eye-opening in terms of some of the unique perspectives that people bring in. But there are ethical concerns, and the considerations are being thought of. There are people that focus in space ethics, space law, to try to make sure that the ethics we define for space stuff gets implemented, right, and enforced. Those are parts of astrobiology, actually. There's space lawyers, which is, you know, I would not have known that years ago, right? That's very unique. But so it is important to remember these things and consider them. Right now, you know, there is an international like Artemis Accord that implies some level of ethical consideration when doing space travel. There's also the Planetary Protection Program, which forces people sending stuff to space to be very cautious of not accidentally sending life, right? That's why, actually, if I even go back here, this is in like a hyper clean environment, and that's true today. They're even much more intense about this. They make sure that no germs or anything like that leaves the planet on these spacecrafts, because we don't want to like accidentally spread life, right? We don't we want to make sure that if we find life somewhere, it's not because we accidentally put it there. But two, we don't want to like accidentally be littering life all over the place. That's not good. So in terms of, the potential discovery of extraterrestrial life, when we think about just like microbial life, there is ethical considerations that need to be made, but I am certainly not an expert in that part of it. When we think about maybe more advanced life, there are definitely considerations to be made, but I don't think people think that that's very likely to happen soon enough for us to need those ethical considerations in place. Although people are working on it, right? Like I said, but in terms of our exploration to other places, we do want to make sure that we're not ruining another planet, right? As I mentioned, I'm very dedicated to climate sciences. We have not done a good job keeping our planet happy. And we want to make sure that if we start settlements on other planets, we are doing that in a resource efficient and a helpful and environmentally safe way, right? So there are these considerations that people are thinking of. We just don't have all the answers yet, right? We don't know enough yet. And yet, Pallet, thank you for posting some of these links to ethical considerations.
All right. So another question. Thank you, Charlie. He said, or he or she said, as a biologist, he had once learned that about stromatolite 7 has one of the evolutionary traces to life on Earth. Could they possibly have their origin from space, or do they have any reference in development of astrobiology and all?
Yeah. So I don't know enough about stromatolites to fully answer that question. The only thing I know is that I do see headlines of astrobiology research involving stromatolites, but again, I don't know enough about the biological processes there to really answer that question too well about if they can tell us anything meaningful about the origin of life. But I know that they are definitely being researched by astrobiologists. And Buzari, if you find me on WhatsApp, I'm happy to share links of those headlines that I've seen with you. You would probably understand them better than I would. So yeah, unfortunately, I don't know exactly the answer, but I do know that they are being researched.
All right. The person that asked that question can just access Ram's WhatsApp link and just go ahead to ask him the question. So it's another question here, and it says, he's an aspiring astronomer, and he has been following the JWST discoveries from the day of its launch. So his question is, the chemical biosignature analysis are quite fascinating, but can we rely 100% on it?
That's a good question. I think as a scientist, we will never rely 100%, right? But and I think it's really important for us to consider, not too long ago, there was reports of phosphine being detected in Venus, on the clouds of Venus. Phosphine is not made naturally very often, and what is made is destroyed pretty quickly. So finding a lot of phosphine, like a detectable amount of phosphine, people thought that might have meant that there was life there, because we know that there is life that makes phosphine and gives it off. Like that's like a biosignature. There's been a lot of research since then that has, one, reevaluated the data, telling us whether or not that phosphine was actually detectable or actually there, and also going into whether or not phosphine could be reliably made naturally there. And lastly, well, I'll just recap as saying, even though we thought that, suddenly there must have been life in the clouds of Venus, and people made good models to predict the amount of phosphine and stuff. It doesn't mean that it was 100% accurate, right? There are other explanations for that being there, if it is there. And the same is true for all these James Webb observations. James Webb is a very powerful tool. It is extremely powerful, and its biosignature analyses are incredibly fascinating. I agree 100%. Can we rely on them 100%? I think that we don't know that answer yet. It will take many people reanalyzing that data because remember that the James Webb just takes the images, right? People have to go through and analyze that data. The people analyzing that data, they might be using a technique to analyze that data that's not 100%. So my long-winded point here is while they are fascinating and incredibly intriguing, we should still be cautious, right? We should wait for that data to be reanalyzed by other people. We should also wait for the James Webb to take other images of it, right? Europa is the big one right now. People are very excited about the recent image of Europa. And it is very exciting. But again, we should wait for that to be reanalyzed, reevaluated, and re-imaged even, right? Science is this process of essentially trying to say no, right? You get a weird result and you try to figure out if that's really true, right? So we cannot rely on it 100% right now. I think that we need to keep working on it. I think we should be excited and keep looking, but yeah, I wouldn't rely 100% yet.
All right. Thank you so much, Ran. And for today's webinar, we've been able to learn. Ran introduced us into space medicine and astrobiology, and we really have to see what space medicine is, not just about the drugs. I'll keep emphasizing that, and just about things that we do, also the activities that we bring down here on Earth and where humans live. Then you also told us taught us how any student can enroll into such program, and that's profound to know that you don't necessarily have to study astrobiology, right? But you can be an expert in your field. Just develop the expertise in your own field and bring it into, astro. And what you said, one profound thing that you said is everyone is an astrobiology. You don't just know it yet. So this is a chat to everyone. Like, try to become the best at what you do in your own field. Get yourself. Remember what Ryan told us. What are you interested in? What are your own interests? Then become better at that. So you can put yourself into that research part or engineering part of astrobiology or space science. Ryan, I have a question. It's quite funny, but let me ask my question. So when people go with this spaceship, right? If I'm correct, like you're going into space. So is it the different people from different disciplines that are inside that, or just selected few that go there?
Yeah, that's a great question. So for example, the for NASA, we recently-ish selected the new Artemis astronauts. And so I'll do a very brief history here. Is at first, when we were picking astronauts, we picked pilots, right? We picked experimental aircraft pilots, people that we thought could take care of the plane, the shuttle, in case anything bad happened, right? So everyone that was on those missions was essentially a pilot, which is great, except we don't need everybody to be a pilot. Even at the time, we really didn't need that. Over time, we've learned that we want to be learning a lot while we're up there. So now I would say almost everybody that goes into space nowadays has a unique specialty, right? So there are doctors, there are geologists, there are planetary scientists, there are astronomers, there are people that you wouldn't expect, right? I don't think any lawyers, or I don't think anyone's gone up for space law yet, like to research space law in space, but it'll happen.
Okay.
So there are, yes, so people are very intentionally chosen. And part of that is you do need people, engineers, right? You need engineers to keep the space station working and operating. But you also want to make sure that you're putting a good mix of people from different academic backgrounds that can do unique research up there. So
Wow. Thank you. So, thank you so much for asking my question. I thought it was funny, but then I think it's a very good question. Thank you. So,
yeah,
and also we learned requirements for being a space scientist and the impact of space scientists in space research and the career opportunities. I think the greatest impact that I can pick is the fact that whatever you do up there, you can apply it here on Earth. Imagine having to create space that is edible because we don't have water, plenty water there. So thank you so much, Ryan. We're really grateful that you dedicated your time to teach us. We're really grateful. And okay, Pal is saying we're already in
Hello.
S is in the fabric of space. Okay. Thank you so much. Can we all celebrate Mr. Ryan? Can we all celebrate Ryan Kirby? Thank you so much. Thank you so much.
Hello.
Thank you, Ryan.
hi Daniel, did you have a question?
Ryan.
Thank you, Ryan.
You're welcome. Yeah.
This is Daniel.
Hi Daniel. Yeah. It's been great chatting with you and setting this up. I really appreciate let me stop my share real quick. Sorry.
Thank you so much, Ryan.
You're welcome. You're welcome. Yeah.
Dorcas promised to join, but I guess maybe she got busy.
Oh, that's okay.
Yeah.
That's okay. Yeah, I'm happy that you guys recorded this so that everyone that wasn't able to join, and it's late for you guys. It must be almost 10 o'clock, 9:30 or something, right?
It's 8:31 here.
8:30. Okay. So yeah, I hope that this was helpful, and feel free to share that recording wherever you'd like, and yeah, I'm glad that everyone that was here was able to be here. So
All right, thank you.
Thank you
All
so
right.
much.
Thank you everyone
Thank
for
you.
joining. So
Thanks,
for
Ryan.
those who joined, thank you, Ryan. For those who joined later, we'd like to let you know that Cyclone is recruiting members. If you'd love to be part of Cyclone. Cyclone is Nigeria-based science club that gives students a place to express their scientific curiosity, develop their scientific knowledge, pursue their interest in engaging in scientific activities. Our goal is to host seminars like we have today's webinar, but also physical seminars, workshops, school outreach and career mentorship, exhibition, quiz competition, and other events to foster students' knowledge and expertise in sciences with a focus on the life club provides opportunity for like-minded people to join through membership and volunteering for projects and programs. Members of the club are from different areas of life sciences, including every individual who has interest in science. So basically, to just put it in a very short statement, people that are passionate about, you're ready to give to your world, you're ready to learn about what science is, what it really entails, and you're ready to give back to this world. Imagine what we learned today. So we are calling for you. You can be part of us. So while our achievements, we embarked on a day-long school outreach program spanning a period of 5 weeks, which involved visits to selected secondary schools within her career. During these visits, we engaged students in science discussions for them to understand various scientific concepts, distributed learning material to enhance ease and comfort in their academic goals. Then, interesting, today is our, September's webinar spanning topics like neuroscience, astrology, careers, scientific publishing. And for this month, we have we just concluded, or we're about to conclude. And our speaker Ranke came to talk on astrobiology and peace medicine. Also, we have a workshop that's coming up in the month of October, and the workshop is tagged Clean Water. And we also have Science Festival that is coming up. But Clean Water is coming up next month, October, and then if you'd love to be part of it, just for a token, you can register. And yes, it's the link will be posted here for those who are interested. for anyone who's interested. So you could kindly send kindly indicate, or you get a link in the chat box where you can read. Thank you everyone for coming today. We really appreciate your time, your presence, and it shows that I believe people that are really passionate about impact, like what we can really do for our world. Right. Right, Daniel. I think you're listening there. All right. Thank you so much, Ryan. We're really grateful. Thank you so much. Daniel, do you have anything to say?
Yeah, Ryan, before you leave, there's something I want to tell you.
Yeah, go ahead.
Okay, I really want to emphasize more on collaboration and networking. You know, SCIENCOON is this organization that has a lot of passionate young scientists, and I know that our club members would really appreciate a form of international.
Oh, you muted.
You're muted.
Sorry about that.
That's okay.
Okay, I'm saying that SCIENCOON is an organization that has a lot of passionate young scientists. Are you getting me? So I'm now proposing like a form of collaboration and networking with fellow international scientists. So if there's any maybe event coming up, you can always reach out to the club so that people here in Nigeria can always link up with those that are abroad.
Absolutely. I like I mentioned, Life to and Beyond, we have this Spacepreneurs program with World Space Week that comes up at the beginning of October. We are pretty far along planning that, which we'd be happy for everyone to come along and participate. But there is always room for us to collaborate in the future as well. Actually, some of the team members from Life to and Beyond are here. We can always plan. We can maybe potentially have some meeting about collaborating on an event together or something. And I'm always happy to chat too if you want recommendations on anyone to come and give a webinar, or if you I'm always feel free, and feel free to give my WhatsApp information to people in your community that want to chat or ask any questions or anything too.
All right, thank you very much for that.
Absolutely. Again, I mean, this communication, collaboration, those are, like I said, fundamental, hugely important pieces to astrobiology. We can't do it without them. So yes, I think this is a great initiative, and I'm happy to help out. Feel free. So
all right, bye.
All right, bye everyone. Thank you so much.
Bye, Ram. Thank
Bye.
you.
Bye. Bye.
Thanks again, everyone.
Ryan, bye.
Bye,
Bye.
everyone. Thank you.
Yes, have a great night, everyone. Thank you.
Have a
You
great
too.
night too. Shegun, why did you Shegun, you mute yourself?
As in,